Hi there. My name is Roman. I work at Square building APIs, and I'm here to talk to you about writing better code. Now, before we get started, just a brief kind of warning. This is my first time speaking at a professional conference. I'm a little bit nervous, so if I get stuck, thank you. This is really good practice, because if I get stuck or start stammering or something, please give me a round of applause. I'll take a sip of water, and then we'll keep going. Now, the reason there's a hammer up there when talking about writing good code is because I'm keenly interested in how the human mind relates to the tools we use. Scientists have studied a quirk of the brain that effectively accepts the tools we use into our representation of our own body. When we swing a hammer, the brain treats our hand and the hammer similarly. It makes no clear distinction between the two. When we drive a car, we think just let's turn left. We don't think I need to move my hands this way and use my feet this way to move the car. And that combination is absolutely magical. A good tool is exhilarating to use. We become augmented. We can do something we weren't able to do before. And every time the tool does exactly what we want it to, we get this jolt of joy, a feedback loop that tells us, yes, I can do this. I am powerful. When a tool doesn't quite work as expected, it's one of the most jarring experiences possible. It feels almost like our own body is betraying us. It's entirely unpleasant. Now, I would argue that the code we write is itself a tool for producing future software. Either ourselves or other developers will use it to build new features, to ship new code in the future. For many of us, even if we're building a product, that code will live on and facilitate a lot more products than what we're currently working on. And that means that we are, broadly speaking, designing a tool even if we're not aware of it in the moment, every time we write code. And it's really important for tools to be well designed. Matt agrees with me, and it's part of why he created Ruby the way he did. He wants people to experience joy when programming, when using the tool of Ruby. And I think the same applies to us when we write code. We must consider not just, does it work as efficiently as it needs to be, etc., but how will it work for the next person who makes a change to it? And that change aspect is really important to me. It's why I think usability is a better word than readability when talking about code, because it's not static. It's something that people are going to work with to do something with it. So we need to ask, will it make people happy or will it make people sad? And some of that is really selfish. I want the code I leave behind to be code that I'm happy to work on. I want others to do the same for me. But some of it is also altruistic. Being kind to my coworkers really matters to me. It is a core motivation in my day-to-day work. So what can we do to make code better? What tools do we have for shaping code? One of my big revelations when I entered the professional software world after graduating college was refactoring code, this idea that you can move code around and change its shape without changing its functionality. And Martin Fowler wrote the canonical book that catalogs a bunch of refactoring patterns and what you can do to code to change its shape. For example, there's a hide delegate pattern where if your object depends on an object that depends on an object, you can remove the dependency on the neighbor by adding a little method. You don't need to read the details. Don't strain your eyes. What I find really interesting about refactorings is that for almost every single refactoring, there's an equal and opposite refactoring that moves code in the other direction. So whether to move code forward or backwards through these is a judgment call. There are code smells to look for, but different people smell different things as bad. So the real answer that senior programmers often tell you is it depends. I see you, senior developers. I see you. But that's kind of awkward, and we really want to have decision frameworks. We want to know where to go. Are there frameworks that help us choose what direction to push the code in? And the answer is actually yes, there are. There's concepts like dry, don't repeat yourself. That's the first concept that I ever learned in this group. And it's, if code looks similar, even if you kind of step away and squint at it and the shape of it looks similar, there's probably something there to refactor. There's probably a concept that you can name and you can refactor, and it makes code easier to work with. There's also a few other concepts. Solid is actually a whole mess of them, all put together. And kind of the thing to take away from all of these, there are different ways to approach the same general idea, which is modularize all the things, right? Split up your code, make it into tiny modules that work well together. And, well, in our strive for perfection, developers tend to over-optimize. We work so hard to write clean code that we lose the forest for the trees and create, you know, web object strategy factory. It's a Java joke, mostly. And so perhaps surprising nobody, there is an equal and opposite reaction to every code design principle. For dry, there's Yagni. There's this idea popularized by Sandy Metz within the Ruby community that the wrong abstraction is much worse than duplication. And there's this idea of composition over inheritance, which in my mind is a rebellion against solid, which is how to do inheritance right in Java mostly. And these counter-reactions aren't just theoretical. All of these were invented by very frustrated engineers dealing with real production issues. Let me illustrate this with a specific issue I've encountered with code that was perhaps over dry, or at least difficult to deal with it without breaking the world. So let's say we have a very simple HR application, and it needs to represent employees. It's going to have a page to show employees, and this is the code to find an employee and send it up over to the front end. It'll also have a page to list employees. It gets a bunch of employees and displays all of them to the front end. Pretty straightforward code. And the presenter that both of these methods are using looks something like this. There's a serialize method. It takes the employees' data and shoves them into JSON format or something. And this is pretty straightforward. It works great. And then a feature request comes in. Add a job title to the employee page. And so if I put on my developer hat and roll up my sleeves and try to make this change given this code, I look at the show page and look at how the employee is being presented. This isn't actually showing me where the fields are, so I click into Employee Presenter. I'm like, oh, serialize employee, that's where the fields are. This is simple, I know what to do. I'll add a field here for the job title. So I find a job, and I print it out, and I'm done. Easy money. Remember that presenter is actually used in more than one place. And let's zoom in on the other use case. Enhance. We go through every employee, and we render it again and again and again, which means that if looking up that employee's job is a database call, because the jobs live in another table, we just created an n+1 query, which means basically for every single employee, we forget that we've talked to the database already, and we ask the database, hey, hello, can you tell me what new information there is? And this is a problem. This will crash your server. It'll slow down your page. It'll page you at 5 a.m. Not that I know that from experience or anything. So let's talk about what failed here. One could say that we should have never added the work of looking up the employee into the presenter. It's too much responsibility for that class. Maybe it should have been passed in instead. And if I was working with only people who were really, really solid at separating responsibilities and being exceptional and dealt with the code exactly as I would have, then we wouldn't have a problem. But users will surprise you. I would never think of hanging up a hammer like this, and I'm not sure it was designed for that. Kind of freaks me out, to be honest. What if it falls? Will it hurt somebody? But if you see something like this happen, if a single person does something you didn't expect, I guarantee it, other people will as well. So you have to start designing for it. So maybe the original sin is actually combining two things which don't belong together because they don't change together. Maybe there needed to be two presenters all along. And just name the other one employee list presenter. Problem solved. Now, change in one doesn't affect the other, and so everybody's happy. And if you're groaning at this because it's exactly the same code written twice in two different classes, I'm with you. This pains me to see this. But at least it won't wake you up at 5 a.m., right? And so I've seen teams argue for hours about questions that are basically shaped like this. Should we combine this code or should we not? Will it change together or not? How should we shape the code to have it be the best representation of the concept under hand? And I think we actually overfocus on code structure, and that's part of the problem. The actual original sin is this idea that we're trying to achieve clean code in the first place. When looking at other tools, we don't refer to them as cleanly designed. We don't say, oh, that rake has too many prongs. It's not cleanly designed enough. No, we focus on how well it works at gathering leaves. We focus on the work that we want to do with it and whether it performs it well. The whole idea of calling the implementation of a tool pure and shaming people who don't adhere to our particular standards for that purity is toxic. And if you have slightly different views on what that purity should look like, hoo boy, that's an easy way to bring a team to a standstill. So perhaps we are asking the wrong questions. Perhaps when we are looking at two pieces of code that perform an identical operation, and by the way, there's not refactorings for going between recursive code or non-recursive code, but people still debate which one is better for a particular algorithm. And you need to have answers if you're going to write something specific. But maybe the question isn't which one of them is better in an absolute moralistic sense. To illustrate it a little bit, let's take the analogy a little bit further. Let's talk about other tools. The hammer on the left is used for working on gold jewelry and stamping patterns on it. The one on the right is a sledgehammer. So this and this. Which one of them is better as a tool? On its face, that question is completely nonsensical. The question is, what are you trying to use it for? And who is going to be using it? Each tool achieves a different result used by different people with different expectations in different contexts. So to figure out which to build, we need to remember the most important aspect of tools, and that's that they're made for people to use them. In my opinion, as I was doing research on Flickr about hammers, this is by far the best hammer. It's structurally unsound, it won't drive a nail, but it's such a joy to play with. And Mats agrees with me again. I mean, not about the hammers. I haven't showed him the hammers, but about the need to center people. And so I want to talk to you about design in a general sense that goes beyond code. Fundamentally, design is about creative solutions to complicated problems, usually problems that are a mix of constraints and open-ended questions. The field of design, in some sense, is a field of applied creativity. And its frameworks help designers build up context about a subject so that they can take intuitive leaps to what are at times completely unexpected solutions. A lot of the point of those frameworks is to get your brain to a point where that intuitive leap is easier to make and is easier to do. It's about improving the odds of those creative leaps. More specifically, since we're centering humans, I want to talk to you about human-centered design. And it's a particular perspective on design that's been popularized over the past 30 years or so that centers on people as a central narrative to drive decisions throughout a design process. It was coined by Don Norman's research lab. Don Norman is this guy. He is a cognitive scientist turned engineer and human factors researcher. He has worked as a safety investigator for aviation, for a bunch of other industries as well, including being one of the investigators selected to investigate the 3 Mile Island incident. This guy really knows about how humans interact with tools. And he's written a book about it. This book is considered the canonical text on usability design. And if you take nothing else away from the talk, and you haven't read this book yet, please look it up and read it. It's amazing. By the way, notice the teapot on the cover is a piece of art called the Masochist Teapot, because it's impossible to use. So human-centered design, sometimes also referred to as user-centered design. I like human because it's a broader word. Centers on three points of view for an analysis: the person, the context, and the action they're going to take. So let's talk about these individually. When talking about a person, when using a tool, for example, a hammer, you're going to want to know how strong they are, how large is their hand, what grip are they going to need. Are they trained in using a hammer? For example, if it's a large and heavy hammer, are they expected to know the proper technique to use it without hurting themselves? Or do you need to design it so that they can't hurt themselves even if they use it wrong? All of these things are things to keep in mind. For coders, we also need to keep this in mind. Is the coder going to be a senior tech lead who has decades of experience, has been slinging code for ages, will know how to debug your really gnarly meta-programming issues in under 2 hours? Or is the person maybe at their very first tech job without having run production code ever in their life, and needs a lot of hand-holding and doesn't even know about refactoring yet? Taking this into account is really important. And the key here is to be really specific and make them real in your mind, because it's not about drawing out those characteristics to like micro-target a Facebook app at them or something. It's about building them up in your mind so you have an intuition about what they might think or they might do. And if you don't have it built up, go out and observe how those types of people actually use the tools that you're thinking about. Observing a junior engineer interacting with code for the first time on a new project is really, really different than observing a senior engineer do this. And if you haven't seen it in a while, go back and ask one of your teammates to take a look at how they work. Just kind of silently observe, maybe ask them why they're doing something. Do a usability study on your team. The other key is explore the edge cases. There's a reason I picked up the contrast of somebody super experienced versus somebody very junior, because their needs are going to be different, and their expectations and the mistakes they make are going to be different. Next up is context. And the hammers you design to be used in different settings are going to have really different requirements, and the people using them are going to have different points of view on what's important about those hammers. If you use a hammer in an operating room, one of the key things about it is it must be easy to sterilize. If you can't sterilize, it's completely useless, because you use it once and you throw it away. On a farm, that doesn't matter at all. In the context of code, there's similar questions. And for that, I want to tell you a little bit of a story. I was working on a side project with a friend of mine, and I couldn't believe the code he was writing. It was gnarly. It was if statements in for loops, in maps, in if statements. I couldn't make heads or tails of how anybody could write code that dirty. I'm used to writing code really, really cleanly, name everything really well, very carefully. And like, we really chafed at each other on this project until I realized that he comes from a movie animation industry. And he has as much experience as me. It was like 5 years of experience each at this point in time. And when animating a movie, when animating the textures for like the waves in Moana or the snow in Frozen, as long as you render the thing once and it looks really good, you don't really need to go back and refactor it and use it again for other waves in another movie, necessarily. The point of your approach and your context is you have to do it fast, it has to look good, you have to be able to change some variables and see what it looks like anew. I'm used to a product development world where products last years and years and get developed over time. And so there's a whole different context to how I approach those problems. And the project we were working on was actually in neither one of those worlds. So neither one of us was absolutely right. What we needed to do is talk to each other and figure out what approach actually makes sense for that project in that particular time. So adjusting to other people's context is really important. And when thinking about what context people have, you need to think about the knowledge they're going to approach the problem with, how they're going to gain it. You need to figure out what their intention is going to be. They're not going to have all the knowledge you have, and their intention is going to be very specific, and often a very specific change. If it's a web form, most likely people are going to add fields and remove fields from it, or reskin it. You can kind of guess what the intentions are. You don't have to be perfect at telling the truth. You don't have to be perfect at being able to predict the future, but you can take some educated guesses and explore the edge cases again. And again, the point is to build up your intuition. And the last thing you need to keep track of is the social environment. Are they going to be well supported? Is there going to be pairing? Are people from another team entirely going to be shipping code to your team? Are they going to feel like they have enough ownership to change your structure? Or do you need to get the structure really right because people will ship code to it and will be really afraid to touch it? These are all really important to consider to make the tool actually useful for the people that are going to be working on it. And finally, let's talk about action. This is the deepest concept to some extent, and I'm not going to cover it in the depth it deserves. To cover it in depth, you really have to read books about it because there's so much to how we perceive things and translate intention into movement and into products in the world. But I will share with you this diagram from Don Norman's book about where mistakes happen and how an action translates to intention and then performance and then back up again. And in this diagram, what's important to look at is how we can kind of look at the different steps that people take in interacting with a piece of code or a tool and provide either information ahead of time before they choose to act about what's going to be the result of their action, or provide them feedback after their act in order to direct them to better paths. And when people approach a tool, they're not often going to use it in an extreme way right away. They get familiar with it first. If it's a hammer, they'll tap lightly on a nail before taking a larger swing just to get used to the tool, right? Same thing happens with code. Somebody is not going to ship a completely new architecture for the code you're working on. They're going to first try small changes, see how the system reacts to those, and build up their confidence from there. And if you do your job well, if you write the code in a way that adjusts their behaviors and guides them with feedback and good error messages, they're going to grow confident much more quickly, and they're going to not cause sevs that wake you up at 5 a.m. So the keys when thinking about action are the perception, then the action, and then the feedback. You perceive a thing before you act on it. You act on it. You get feedback, you reflect on it, and then you repeat the cycle again. And at every one of those steps, there can be mistakes and there can be opportunities to make that cycle better. So let's just touch point again. Human-centered design is a framework for helping you make decisions and communicate to others about those decisions from the point of view of a person, their context, the action they're going to take. And I believe you can use this to resolve those arguments that you have, to step back from looking at the structure and talk about who's it going to affect. Does it make it less risky for them to do this change? Does it help them do it in some way? And if the answer is neither structure does much for the user, doesn't matter. Choose one of them and move on with your life. Like, sometimes it literally doesn't matter. Flip a coin. If you can't get back to how it affects people, then maybe the decision isn't that important in the first place. Now I want to go back to the code problem we were faced with earlier. We have a solution to the quandary, whether to have 2 presenters or 1. Our answer was to just have the 1 presenter, but with a caveat. What we did was we looked at where it's being used and realized that it's very likely for it to be changed unintentionally, causing side effects in a different place that a person isn't looking at. And so what we did is we changed that part of the code to provide better affordances and better feedback. We added this thing that we call without DB, which wraps a block of code and replaces your database connection with a really simple class that throws an exception if it's used. And so we kind of took a step back, thought about the failure cases, how the system can guide people to better behavior without expecting every single person to always code perfectly every time. And we realized that we can change the code in a way that provides that feedback. Now, if somebody is not looking at this class, they will be warned if they're going to do something dangerous, and only if they're going to do something dangerous. This completely gets out of the way if they're doing the safe thing. And that's another important aspect about tools. Tools should get out of your way if you're not using them, if you don't need them right now. Tools that you keep stubbing your toe on even when you're doing everything right aren't good tools. Sorry, just going to take a sip. Thank you. And so that's what I want to ask you to do with your code, especially when you're not sure which way to direct it. Sometimes the answer is obvious. Sometimes the structure will give you enough. A hammer has certain properties that all hammers have to abide by. But when you're not sure, especially when you're arguing with your teammates and going in circles, take that step back and use this framework to ask yourself, who is it for, and how will it impact them? And then sometimes you get to creative solutions that you wouldn't think about beforehand. So I want to, I didn't mean to animate this. Oh, well. This is a list of just things that I've been inspired by in this talk. There's some videos and some books. I highly recommend, if you're interested in these subjects, to look them up. Sorry. These are about code quality. There's some about design as well. This is not at all a comprehensive list, but these are the things that I learned from. I want to especially call out WebEtex, which was my very first job, and it's where I learned about design and contextual design research. They're a Chicago-based design research and development firm. And so thank you for being here, and thank you for supporting me up here. And thank you for Square for letting me, supporting me getting out here and speaking. Are there any questions? The question is the function without DP open source at all? It isn't yet. It was actually based on a very small tweak to an open source gem. I'm blanking on the name, but there's a gem where if you have multiple databases, you can choose one of them. And basically, what we did is instrumented so you can choose no database instead. Well, come get me after we wrap up if you want to talk one-on-one. I do have stickers of lemurs from Brandon's talk. And I have a lot of horror stories to share about really bad UX and code. And the one senior architect who first inspired me to do a talk on the subject in the first place. They're not at Square, don't worry. But I have a lot of stories to tell you if you're interested. Thank you.